Alright, so this is my presentation on soap bubble optics. So a bubble is, of course, soap encasing air, but what you don't know about that film that surrounds that air is that it's actually made up of water surrounded by soap molecules. And really, it can be really any surfactant, which is what soap is. So one part is hydrophilic, which means it likes the water, so it tries to stay there, and another part is hydrophobic, so it stays away from it and goes towards, the air on the inside or outside the bubble. When bubbles come in contact with each other, they share this wall between them, and if they are of the same size, that wall will be flat, so you can see that it's like a line. And if they are unequal in size, and it doesn't have to be this dramatic, but it shows through better, then the smaller bubble will actually curve into the larger one. And so when you do foam, which is 3 or more bubbles, then it'll still conform to that, but you also have this additional rule of bubbles being at 120 degrees, which is similar to a beehive, and how that looks where everything's a hexagon, and it shows really well in this picture. And there are usually 3 bubbles to 1 point, so it's like 1, 2, 3, but you can have a 4th one like this if it's resting on top of it. And so bubbles pop because they interact with something. But if it isn't caused by some sort of outside interference, then it's likely because the water has drained down to the bottom of it, because, as you saw earlier, it's basically a sandwich of soap, water, soap. And so the water gradually drains down to the bottom of the bubble because of gravity. And so that's how you get that water droplet that you see at the bottom of bubbles. Another thing is evaporation. So the water gradually goes away, and that thins the bubble to the point of popping. And if you can see the iridescent surface, as soon as it's about to pop, because it's really thin at that point, you'll see this sort of speckling thing right before it pops. As for reflections in bubbles, it shows twice because, it goes off of the first surface, the outside, and then it bounces from the inner surface to your eye. So the image will appear twice, but one of them will be flipped upside down and horizontally. Good stuff. And there's also a video of a freezing bubble that you can click on. Links down below. It gives you a good idea of how the physics works for freezing bubbles. So for a bubble to freeze, it has to be about negative 15 degrees Celsius, and that will cause it to freeze on contact with the surface. Whereas if it's 25 degrees or lower, it'll freeze mid-air. Now, iridescence is where it gets a little tricky. It's not easy to emulate. You have your incoming white light, and it has multiple surfaces to bounce off of, as you can see. So sometimes it'll bounce off the first layer, sometimes it'll bounce off the second layer, sometimes it will go into the bubble, bounce around any number of times, and then come out. And so when you get to this part, that's where you start to see some of the color stuff going on. So if they're both doing a similar thing, they'll just add up and double. But if you've got this sort of thing going on, then they cancel each other out because they're going the opposite of each other. And so that's why it's not just white light. And so you get these sort of patterns where they are all swirly and colorful. So these are some references that I thought were really, really good. Those will also be in the description. So thank you. I hope this was helpful.